Okay, so welcome to this video. So in today's session, we want to look at this question from physics. So let's just dive in, solve the question together. Okay, so let's read the question. So the diagram below shows two forces acting on the box. The box of mass 80 kg rests on a horizontal surface. So you can see that there's this force here and this force here. So we have a 50 newtons force acting to the right and a 30 newton force acting to the left, and the mass of the box is 80 kg. So the question says calculate the net force on the box and the acceleration of the box. Okay, so what are we supposed to do? Okay, so let me just drag this thing. Put it somewhere. Okay, so let me just transfer this here so that we have clear view. Okay, so this is what we have. So we know that we need to find the net force and the acceleration. So before anything else, so let me first of all introduce you to something. So we have two forces acting on the box. Here we assume there's no friction on the box. So what we know is that the box has something called the weight. So the weight of the box should always act downwards. So if you were asked to draw the direction of the weight force, it should come from the center there, downwards there. So this is the weight mg, because weight is equal to mass times acceleration due to gravity. Okay, apart from that, you can see that there's this surface here. So this surface also has another force that acts on the box. This force acts in a direction such that it balances the downward force. It balances the weight force. So this is the normal reaction force from the surface. So the surface will also exert an equal force. So this equal force is also equal to mg. So this is the normal force. Okay, so that is the normal force. Let me just do one thing here. Okay, so let me just bring this here. Yeah, so we're saying the surface is also acting on the box by an equal amount of mg. So we have another force now acting in the opposite direction to the weight force. So this force balances the weight. So if you were to calculate the weight force here, mg, you can see the mass of the body is 80 kg. Let's assume g as 10. So multiplied by 10. So the weight is 800 newtons. So it means that the net force, the normal force here, which balances the weight, is also equal to 800 newtons. So in other words, the box cannot move in the y direction. So it cannot move in this direction because the forces are balanced. So the acceleration in the y is 0. Okay, so that is why they're asking us to say find the net force. So to find the net force, you can see that the box will only have a net force in the x direction. It only has the net force in the x direction because the forces in the x are not balanced. We have 50 newtons here and 30 newtons here. So to find the net force, we shall say the net force is equal to, you can see that there's a 50 newtons here. So because the two forces are in the opposite direction, so every time we have a situation where the forces are in the opposite direction like that, so we have F1 and F2. So the net force is equal to F2 minus F1. But if we had a situation where the two forces are acting in the same direction, F1, F2, then the net force is equal to F1 plus F2. But here you can see that 50 newtons goes to the right, 30 newtons goes to the left. So we need to subtract. So let's find the net force here. So the net force is equal to F1, or we can say F2 minus F1. So if this is our F1, this is our F2. So this will be equal to 50 newtons minus 30 newtons. So therefore the net force F is 20 newtons, and it acts to the right. So you can see the direction of this force is to the right, because that is where we have a bigger force. Okay, the second question asks us to find the acceleration. Now, to find the acceleration of the box, we need to use something called Newton's second law of motion. So according to Newton's second law of motion, what does Newton's second law of motion state? So Newton's second law of motion states that the acceleration of the body is directly proportional to the net force, but inversely proportional to the mass. So you can see there's a direct relationship between acceleration and force, but there's an inverse relationship between acceleration and the mass. So what it means is that every time we increase the force, the acceleration also does what? Increases. So if the net force, this F is the net force, the resultant force. If the net force increases, then the acceleration should also increase. But if we increase the mass, then we reduce the acceleration. This makes sense because if something is heavy, it begins to move slowly. So increasing the mass, you reduce the acceleration. So Newton's second law of motion is usually written like this. So we write this: A is equal to F over M, or commonly seen as F is equal to ma. So this is Newton's second law of motion. So we're going to use this one to find the acceleration. Remember, we have the net force and the mass. So let's find the acceleration. So we're going to say acceleration is equal to F over M. So the net force is 20 newtons. We got the net force here. And the mass is 80 kg. Remember the mass here. So you can see this 0, and this 0 cancel. So 1, 2 there, 1, 2 there, 4. So 1 divided by 4 is the same as 0.25. So this will give us 0.25. Now what are the units for acceleration? Meters per square second. So we now conclude and say, therefore, acceleration is equal to 0.25 meters per square second, and the body accelerates to the right. It accelerates in the direction of the net force. Okay, so there you have it. That's how you do it. Bye bye. See you in the next video.